In this video, we're going to be going over the correlation coefficient. So it's denoted by the letter R, and this tells us the strength of a linear relationship between two variables. So a value of R between -1 and 0 is negative. The closer the value is to -1, the stronger the negative relationship is. When R is 0, there's no correlation, or the correlation is inconclusive. When the R value is between 0 and 1, the correlation is positive, and again, if R equals 1, then the correlation is very, very strong positive. So if you're doing an example, we have two variables, x and y, and we have some data with those. We're going to use this equation to determine the correlation coefficient. So what we need to do is we need to make a table of 5 columns. So we need the columns of x, y, x multiplied by y, x squared, and y squared, because we're going to need all of these, either the summation in this. We also need to know how many pairs of data values we have. So we have 1, 2, 3, 4, 5, 6, 7. So n equals 7, because we'll need that in this as well. So for all of our x values, we put them in. Put in our y values. And then we do x multiplied by y. And of course we're doing it across. And 15 times 7 is 105. And then we do x squared. So and y squared. So now that we have all of our columns, we need to find the summation of all of them. So that basically means we need to add all of them. So draw a line, and we want the summation of all of them. We can draw columns. So we add the x column, to get 28, y column, to get 59, xy column, to get 296, x squared column, to get 140, and y squared column, to get 629. So now that we have that, we are going to plug it into this equation that we have here. So if we write it with the numbers in, we have R equals n, so 7 multiplied by the summation of x times y. So that is this number, because we have x times y values here and we've added them all up to get 296. Now we minus that by the summation of x multiplied by the summation of y. So we minus it by 28 times 59. Then we have a divide and a square root. We have n, so 7 multiplied by the summation of x squared, which is 140, minus the summation of x squared. So notice how the summation of x squared is x squared, all the x squared values added together. The summation of x bracket squared is this column squared. So this would be minus 28 squared. Close bracket, open bracket, we have a 7 multiplied by the summation of y squared, which is 629, minus the summation of y bracket squared. So it is this column, it's 59 squared. So now that we have all of our numbers in, we can do the calculation on our calculator. So we get an R value of 0.988. That's the three significant figures. So with an R value of 0.988, looking at these graphs, we can see it's positive. So it's definitely a positive correlation, and 0.988 is very close to 1. So the correlation we have in this data is very strong. Oftentimes, if the correlation, i.e. the correlation coefficient, isn't close to 1, so like 0.6 or 0.4, then we can test the correlation coefficient